welcome to infinity and beyond, where of course infinity stands for 65,536. My name is Sebastiano and I'm an Android engineer. So before we deep dive into the whole 65K limitation problem, we need to give it a little bit of context. So as you know, the Android community is great because you get the chance of working with awesome developers who also happen to develop things like open source libraries and frameworks, which in turn we can use for free. And these libraries and frameworks address some of the most tedious and common problems that we have to face whenever developing an Android application. For instance, if you think about, I don't know, loading an image from the internet and displaying it on your device or performing a network requests, all these tasks are very common and are spread throughout the application many times, and you do it many times per day. So having a library that addresses that precise problem in a very efficient way is very good for us because we get the chance of developing faster and more reliably. More reliably because typically what happens is that these libraries or frameworks are already tested by the people that develop them. So there is no need for us to test them again, right? And so by using stuff that has been already tested by others and that is already used by tons of people in the community gives us more confidence in the product that we are building. However, we should be pretty much careful about how many libraries and frameworks we actually stuff into our application because as we're going to see throughout this presentation, there are going to be some drawbacks. So, quick question. Who in this room has ever had troubles with this number concerning the number of methods before? Okay, I see some hands, which is nice. I see some hands not being raised, which is even nicer for them. Before getting to know where this problem comes from and what we can do about it and why did anybody do nothing about it, we need to get familiar with the Dalvik executable format, or the DEX file. So a DEX file is basically a container for all the application source code, the compiled application source code. And in a high-level way, you can imagine that the Java code that you write, all the classes and methods and stuff, gets processed by a tool called Javac, which produces class files. And this is basic standard Java compilation toolchain. However, on Android, another tool called DX takes all these class files and processes them even more and turns them and packs them into a DEX file. This, of course, changes with the latest release of the Jack toolchain. However, the mechanism is roughly the same. So you take an input Java files and you produce a DEX file. The question that arises from here is where is this 65K limitation coming from? Is it something at runtime? Is it something wrong with the DEX file format? What is it? Well, it turns out it's not in the runtime. It's not in the DEX file format either, but it's inside the Dalvik's instruction set. So as you probably know, the virtual machine for Android is called Dalvik, the Dalvik VM. And if you take a look at the Dalvik instruction set documentation, you're eventually going to find this particular command or instruction, which is invoke kind. And if you see here, there is a second parameter that is called method reference index. And its length is precisely 16 bits. And 2 to the power of 16 is 65,536. What this whole thing means is that we can put how many methods we want in our APK, in our application, but since this field's length is 16 bits, we will be able to only reference the first 65,536. The others stay outside. There is no way for them to fit inside this particular field. And this is why there is this dreaded number that is causing us developers so much trouble. And for those of you who hadn't the chance or were lucky enough not to be dealing with this problem, you can ask yourself, do I know when I cross the limit? What does it happen? Well, you will know for sure because the first thing you're going to notice is that you're no longer able to build an APK for your application. And the natural consequence of this obstacle is that you're going to panic. And you're going to rush to Google and type, my application doesn't build anymore, what do I do, please help. And eventually you're going to end up taking a look at the console. And depending on the build system you're using, you're either going to see the message on the left and most likely the message on the right, which is trouble writing output, too many field references, blah, blah, blah. Maximum is 65,536. And yeah, so this is actually where the problem comes from and how to get to know it. But the point here is what we can do about it. Is this going to change? Is there a solution for it? Why didn't Google address it in the first place? Well, it turns out that it's not that simple. Because if you recall, we said that Android has a thing called the Dalvik virtual machine. And with more recent versions of Android, Google switched to another runtime, which is the ART runtime. And this means that if Google decided to change the Dalvik's instruction set by, making it a larger field to hold more methods, it would mean breaking retrocompatibility with previous runtimes for Android. So it means for a developer, if it targets, for example, Lollipop and beyond, it wouldn't be able to make his application run on previous versions of Android, which is a big, big issue. However, since Google was actually aware of this problem when he was writing ART, they gave us a way around this limitation, which we're going to see in a few minutes. But then let's go through each possible solution to this problem and see what are our chances of fighting it. The first thing is using Google's own solution, which is the official one, and it's called multidex. The second approach is getting our hands dirty and creating a secondary DEX file or more and load them by hand at runtime. And the third approach is using the shrinking technique plus thinking about what we're doing and what is the state of our application if there is something that we can do to reduce actually the number of methods. But let's start with the first one, which is Google's multidex. This is probably the go-to solution when you encounter the problem and you Google it and you're going to end up in the official documentation about this problem. However, pay attention that even though this is the official approach to the problem, it is not the recommended approach to the problem. And while this might sound weird as of now, later on in the presentation, I'm going to give you an explanation on why this is not recommended per se. And since we mentioned that now we have two runtimes to deal with, which are Dalvik and ART, there are going to be different working mechanisms for this approach. And here they are. So what happens let's start with ART first. As you can see here, you see that in the new versions of the runtime, multiple classes.dex files are processed by a tool which is called dex2oat and turned them into an OAT file. So what happens is that the application source code is compiled and ends up in one or more dex files. At installation time, the operating system takes these DEX files, gives them to the dex2oat tool, which produces an OAT file, which is basically ELF code, so executable, linkable format, close to machine code. However, on Dalvik, a single classes.dex file gets processed by a tool called dexopt, and which turns it into an ODEX file, which stands for optimized DEX. And as you can see from this chart, there is a single DEX file which is processed, and the Dalvik runtime won't even care about more DEX files that you may put inside your application, because it is going to look only for the one whose name is classes.dex. It won't even bother looking for others that are classes-1 or classes I want more methods or anything like that. So just the one. And this means that since this is how Dalvik was designed to work, we need to do something at runtime to circumvent this limitation. And that is precisely what multidex does. But Assume you just hit the problem, so you are no longer able to build an APK for your application because you put too many methods inside. What do you do? What does it take to get multidex to run? So the first thing you got to do is let Gradle know that you want multidex enabled for your application. And this is as simple as adding the multidex enabled to true line in your build.gradle file. The second thing you need to do is include in the multidex support library to the list of dependencies for your application. And again, super easy, just one line of code in the dependencies, and you're good to go. And finally, you need to make your code aware that you are using multidex. And there are 3 ways of doing that. The first and the most simple, and probably the recommended one, is by specifying the name for your application by referencing the multidex application inside the android.support.multidex package. If this is not an option for you because maybe you already have a custom application class, then you can make this custom application class extend multidex application instead of the base framework application one. Even this might not be an option for you because maybe you're already extending our application class, so there is a third way, which is overriding the attach-based-context method and calling multidex.install in it. So let's go through the advantages of using the official approach by Google. Well, the first thing is that it's very well integrated into the build chain, so there is no need for you to pull off complicated tricks or do magic stuff to make it work. It just works. And the second point is that multidex is a support library, so this means working across every Android version since, I don't know, Froyo or Gingerbread, I don't recall. So the thing is, there is no need for us to handle things differently according to the different Android versions we are targeting. And the third point is that it's like really simple. You hit the problem, you follow these 3 simple steps, and you're good to go. You're building again, you can start working again on your application. So props to Google for that. However, there are, of course, some disadvantages. The first one is that you are not really in control about what parts of your code base end up in the main DEX file and what other parts end up in the secondary DEX files. And this is not a big issue for like the majority of the developers, but sometimes you have to deal with I don't know, libraries that require native components, which in turn require classes to be loaded at the startup time of the application. If this native library doesn't find those classes whenever it starts, then it's going to be trouble and your application is going to crash. So there might be some issues if you're like the library you're using is very particular and very specific and maybe relies on native components. And also, as per Google documentation, anything below Lollipop is unreliable when it comes to multidex. Because, as we said before, all these versions from ICS to KitKat still run on Dalvik. And it's nothing that we can do at the low level to patch Dalvik. It's something that we need to handle at runtime. So this means instability by default. It's not like, again, it's not that your application is going to crash every now and then. But there might be cases when the user experiences a crash that is due to the multidex. Also, we need to take into account that these additional DEX files are loaded at runtime. And this means that whenever your application starts, these additional DEX files have to be processed and then have to be loaded in memory. And this takes time. Time which is spent by the user waiting for your application to start. And this is generally a bad idea. Like the user doesn't ever want to wait for nothing. So this is, again, another issue that has to be considered. And finally, for us developers, since multidex requires some extra processing to figure out which parts of your code base can be safely put inside the secondary DEX files, this requires time. So we are going to experience longer build times in some circumstances. There is a way around this problem, kind of a trick. So if you create like a working flavor, a Gradle flavor for like debug builds, you can specify min SDK to 21, and then all the multidex extra processing is not going to happen. So you are back to your original build times. So yeah, this is it for the Google official approach, and we can move on to the second approach, which is the hardcore one, not for the faint of heart, which is loading secondary DEX files by hand. So historically, it's not like multi-DEX was there for us when the problem started to become more frequent. Instead, an article published in 2007 by a Googler at the time was suggesting the possibility of creating manually additional DEX files that were to be loaded at runtime by the developer itself. And it was a combination of the Ant build mechanism, which was the one before Gradle, and using interfaces to actually load, to actually be able to interact with classes inside the secondary DEX files. And roughly, this is how it works. So you basically take a library, let's say that it has a jar file, and you manually give it to the DX tool in order to produce a DEX file. So you manually create a DEX file for that library. And here comes the first limitation. So this works only for jar files and for parts of your code base that do not require resources. Because, for example, AR files, which may contain resources, these resources are not going to end up in the DEX container because DEX is only for source code, not for like images or XML resources, anything like that. So this is the first limitation of this problem, this approach. And okay, so we have this additional DEX file, and we put it inside our APK. Whenever like the application starts for the first time, maybe the user has just installed it, we need to take this DEX file, copy it into an appropriate directory, create a custom class loader that loads classes from that additional DEX file, and pay attention that a secondary class loader, like a custom class loader, is different from the main one. So it's not that you can load these classes and like try to invoke a class or a method inside the additional DEX file and it's going to work. You need to find a way to interact with those classes at first. And there are basically two ways of doing that. You can either use interfaces or you can use reflection. So the first thing you should be like moving to is of course interfaces, because reflection is going to be a pain. And you would be right. However, there are cases and were cases in the past where using interfaces was not an option. And it happened to me for the company I was working with before. So we had to rely on reflection. And just to give you a hint about how painful it is, let's go through this brief example. So we have this 3 lines of code from the Twitter for J client. We just want to instantiate the client and set the consumer keys and the access token. Pretty simple, 3 lines of code. How hard can it be to turn it into reflection, right? Pretty hard, actually, because if you see, this is totally not understandable, totally unmaintainable. We have to only work with three objects, which are object, method, and class. Reflection is also very slow to work with, so you need to find a way of caching the lookups for classes and methods. In fact, you can see that there is a method which is called getClassCached and getMethodCached. And so this is really not the way to go when it comes to invoking stuff that is not in the main DEX file. However, at the time, it was our only option, so we had to go through this. And it's not something that I recommend, unfortunately. And this technique, of course, has advantages over maybe Google's multi-DEX approach. And the first one is that you are totally in control about what goes where, because you are the one creating the additional DEX files, right? So you can decide that a particular library or a certain part of your code base can be very well isolated from the rest, and you can stuff it into a secondary DEX file and like load it lazily whenever you want. And this is the second main advantage, that you are in control about when to load these secondary DEX files. Take, for example, the Twitter for J client example that we've seen before. Maybe our users do not want to interact with Twitter at all, and we are burdening them with longer startup times just to load the Twitter class and the Twitter stuff. They don't want to use Twitter, so why bothering, right? if we are in control about when to load these secondary DEX files, which may contain the Twitter4j library, we can decide, hey, the user has reached to a point where he may interact with Twitter. Maybe he pressed the I want to tweet button. That is the right time to load the additional DEX file, the additional classes from the secondary DEX files. Because the user maybe is going to wait an additional, I don't know, 200 milliseconds, which is good at the time because you would still be loading stuff from the network, and it's a nicer time to perform this operation rather than the startup time when the user is just going to stare at a blank screen or a white screen. However, there are two advantages and many, many, many disadvantages. Sorry again. The first one is that it's, as you can see, is pretty hard to set up. So again, you need to create manually a secondary DEX file by using the DX tool. You need to stuff it into your APK. Whenever the application is installed and is run for the first time, you need to take the DEX file, copy it into a proper directory, create a custom class loader, load the DEX file with that class loader, and then try to find a way to interact with it, either by interfaces or reflection, which is a lot of work. And especially if you rely on reflection, it's going to be even more painful. And if you think about it, you are putting parts of your code base inside the secondary DEX file. Back to the example of Twitter. What happens if the Twitter4j library gets an update? How do you handle it? You don't want to, every time the application starts, you don't want to take the additional DEX file, copy it again into the proper directory. Because if if there were no updates between one launch and the next one, this is simply a waste of time, right? So you need to handle the versioning of the additional DEX files yourself, which is even more work. It's, again, extra work to do this. And this was something that we did back in the day where multi-DEX was not an option. It wasn't there yet. However, to this day, there are some improvements to this technique. And actually, we can steal some of the ideas that power Google's multi-DEX solution. So basically, at the low level, what multi-DEX does, it patches at runtime the Dalvik class loader, so that this class loader can look for additional DEX files in the application directory. So we can take advantage of the same technique together with specifying the dependencies via Gradle as provided. So specifying dependencies as provided means that we can type the code as if the classes were actually there. They are going to be resolved at compile time. However, they are not going to end up in the final APK when you build it. And that's exactly what we want, because those classes are going to be in the secondary DEX files, right? And this is kind of the nice best approach between the two techniques, because then you are in control about what parts of your code base end up in the secondary DEX files. You entirely remove the need for interfaces and reflection. However, there is still the problem that you need to create the DEX files manually and handle them yourself, and you're not in control about when to load stuff because you're still relying on the multi-DEX library. And with that, we can move to the third technique and the third way around this problem, which is using the shrinking technique plus a little bit of thinking. So remember at the beginning of the presentation when I said that Google's multi-DEX approach was the official one, but not the recommended one? Well, take a look at this. And I quote, "You should take steps to reduce the total number of references called by your app code." This is not something that I have written. This is something that comes directly from Google multi-DEX documentation. What this thing means is that you should try as much as you can, and it's Google telling you that, not me, to stay below the limit. This is the main takeaway of this sentence. And this means that you need to struggle to try and stay below the limit as much as you can. Try to be considerate about what frameworks and libraries you use, or if you are maybe misusing something or not using it into the way it was designed to. And the best tool that we can take advantage of to achieve this result is, for sure, ProGuard. So I assume everyone in this room is familiar with what ProGuard is, so I won't bother you with details. Just to go through a brief definition, is a tool that allows us to shrink, optimize, and obfuscate our code. By shrink, we mean that ProGuard takes the source code and removes all the unused methods and unused classes, and that code, everything that is extra, that is not used by your application actually. It is able to optimize the code by trying to make it faster and by making it consume less memory. And is also able to obfuscate your code, meaning that it mangles the names of the classes and the methods so that an attacker has an harder time trying to tamper with your application. It's super great because it works both for the code that you write, like those Java classes you write, and also for third-party libraries. So if you're using something that has not been ProGuard touched, you can do it yourself and actually process those third-party classes. And what many developers do not realize is that ProGuard has a huge impact on many different aspects for your application. So if we go back to the shrink part, if you think about it, shrinking means removing extra stuff. This means a smaller APK, which is really great for the user, ultimately. It means a lower methods count, because we are removing stuff that we wouldn't use anyway. And by optimizing the code, it has an impact on performance, so lower memory footprint and maybe faster calculations. And also security. As we said, obfuscation means harder time for attackers to try and steal our precious purchases. And I won't be going into details about how ProGuard works, just a few pills that you need to keep in mind when working with it towards reducing the number of methods for your application. So ProGuard, by default, assumes it has to touch everything. It means it has to shrink everything, optimize everything, and obfuscate everything. Of course, this might not be the case for all of your code base. So if you want something not to be touched by ProGuard, you write an exclusion rule or a configuration rule, whatever you want to call it. And the thing is about rules that they need to be as specific as possible. Take a look at these 3 examples here. The first one is telling ProGuard not to touch anything inside the com.google package. This means not shrinking, not obfuscating, and not optimizing it. The second rule, even though it differs just by the names suffix in the keep statement, tells ProGuard, hey, please, just don't obfuscate anything inside the com.google package, but please do shrink it and do optimize it. This means that if you think about Google Play services, for instance, which are huge, it's 60,000 methods, I don't know, very, very large, probably for 40,000. If you think about not shrinking it, it means that you're basically just include them and you're out of the 65K methods limit, right? So this is extremely important not to tell ProGuard to actually shrink that package, right? And the third rule is even more specific because it's telling ProGuard not to obfuscate anything that is annotated with the keep name annotation from that package. So we go from less specific to more specific, and this means much more methods inside our APK, much less methods inside our APK. So the more strict, the better. A quick quiz, a quick question to keep you awake. Can you tell at a glance what is wrong with the following keep rule? And while you think about it, let me give you just a bit of context. This was something that was posted in the bug tracker, and it was related to a bug, something that was introduced by Samsung, because of course, Samsung, what does it do? It introduces bugs. And actually, this was the solution that was provided by one of the users. And it was something that was actually in the code base of the company I was working with before. And when I noticed it, I stared at it for a little, and then I noticed it. We are telling ProGuard not to touch anything inside the Android.support package. This means that the whole bunch of support libraries were not shrinked, not obfuscated, and not optimized. When I removed the statement and substituted with something more strict, more precise, the number of methods that were saved inside the application were almost 6,000. So 6,000 more methods out of 65,000 that we were suddenly able to use for our code rather than getting wasted by doing nothing. So again, it's really important that you understand those rules and that you write them properly. And to this very subject, you should know that there are default rules for ProGuard. You can find them in the SDK folder. And for instance, native methods, which are the ones that are called via JNI, are kept by default by ProGuard. And if your company is very considered, considers security like a matter of importance, and maybe wants to, I don't know, to have extra layers of protection, or is very considerate about the number of methods, that might be the case to use DexGuard, which is the paid version of ProGuard. Yes, it's like you have to pay for using it. It doesn't come cheap because it's like very expensive, but then it comes with many additional features. You can encrypt basically everything from the code to resources, strings, native libraries. It comes with stronger obfuscation with protection from attackers, tamper detection, its own version of multidex, and much more. And it comes with also pluggable encryption. So you have this unique way of providing components to the encryption system so that your application's encryption is unique. And this is even harder for an attacker to understand the working mechanism of ProGuard, of DexGuard. And the thing is that about the number of methods is that default rules are much more extensive and much more well-written, and they support out-of-the-box stuff like Google Play Services, support libraries, the most famous libraries by Square, and so on. We can skip that because we don't have time. And let's move to the final part of this presentation, which is we've been talking about like the number of methods, how many methods per library, and how many methods does our application have. How do we count them, actually? What are the tools that we can use to count the number of methods for libraries and our application? Well, I'm going to give you some of them, which I use on a daily basis, some of them. And the first one is the most simple one, which is inloop's APK method count. It's basically a website where you drag and drop the APK, and you can see the total number of methods. You can even see if multidex is enabled or not, but you can tell yourself if it's higher than 65K. And you can see the per package output of the number of methods, so to easily spot the culprit for a high count of methods for your application. It's like really as simple as it gets. Also, don't worry, the APK is not like traveling to some third-party server. The computation is done locally on your machine, so it's safe. However, it's not really something that we can use daily when we build our application and want to check the current methods count. It's really too cumbersome to do that. And another tool that I feel like recommending is ClassyShark, which is a Java tool developed by a Googler very recently, like this year. And it's a tool, it's like a multi-purpose tool to analyze APKs. It is able to tell you the number of classes, the number of methods. It also acts as a simple decompiler, so you can actually take a peek on the source code of third-party applications. And this is roughly how the interface looks. You can see the number of methods per each package. You can see this nice pie chart. If you hover it with the mouse, you see the number of methods per each package, and so on. Also, if you select one of the Dex files inside the APK, you can see a more detailed view about the number of classes, the number of fields, the number of methods, and the number of types, and so on. So very detailed information about the application, and allows you to analyze an application even though you are not the one who wrote it. Again, this is a very multi-purpose tool, a very not specific tool, and so it's like super useful, but it doesn't help us when it comes to something integrated in our build chain, right? So talking about something that is more integrated with our build chain, this is the DexCount Gradle plugin. So it's a Gradle plugin developed by KeepSafe. And the nice thing about it is that every time you build your application, you can open the Gradle console and see the number of methods used and the number of methods left in your application just by opening the console. It's going to be right there, so you don't ever think about it anymore. Whenever you want to know it, you just open the Gradle console and it's going to be there for you to see. If you want to see more detailed information, you can open the build directory for your application, and there's going to be a txt file inside it which lists all the dependencies with the number of methods per each one. So just to give you a little bit of context, that is the output on the console. So you can see the total number of methods is almost 16,000 with the percentage, and we see that we have close to 50,000 methods left for our application. So it's very convenient. And this is like the txt file that lists all the dependencies for different packages with the number of methods per each one. And this is like super nice, and this is something that I use on a daily basis. However, if I want to see which are the culprits for a high count of methods, this is really not too fancy, not too comfortable, because I have to go into the build directory and find the file, open the file, find the package, and see the number of methods per each one. Something that improves this is methods count, which is another tool that I'm particularly fond of, probably because I made it, together with two friends of mine, Nicola and Dario. And it's a tool for developers, by developers, to allow you to see the number of methods and dependencies for third-party libraries before having actually to put them inside your APK and before having to actually hit the limit. And it's also useful because then you can compare different libraries, not only in terms of functionalities, so this library does this rather than that, but also in terms of how many methods does this library have, how many dependencies does it rely on. Do I have many of those dependencies, or like I don't have any, so the number of methods extra is going to be higher. And we have now more than 20,000 libraries inside our database, and it's still growing because every time you hit something that has not been calculated, it gets calculated on the fly. Otherwise, it's cached, so it's going to be instant, pretty much. And for each entry, you can see the number. You can see the DEX file size. You can see the direct count for that library plus the dependencies count per each one of them. You can see, of course, the total count for the whole library with its dependencies. You can browse for multiple versions of the same library, and thanks to the newly introduced charts, you can actually see the trend of the number of methods and on the library size over time. Also, like, this is the interface, so it's pretty simple. I made it, so don't blame me if it doesn't look too fancy, but I'm no web designer. You see the total number of methods and the dependencies. If you click on the button, you can see the list of dependencies per each library. You can browse for multiple versions and everything I just said. Also, it comes with this nice Android Studio plugin, which allows you to see the number of methods per each dependency entry inside your build.gradle file. And it's very convenient because you can then take a library, put it inside your build.gradle file, and it's going to be you're going to see the count right away, like this. So we can see the number of methods plus the number of dependencies. If we want to know more, we can just hover on the blue circle to the left, and we can see the number of methods per each dependency. If we want to know even more, we can click on the blue circle, and we're going to end up in the website. So methods count is great because it gives you so many informations to work with without having actually to hit the limit. However, and comes with a nice plugin. However, you should be careful about reading those numbers because since ProGuard, the way ProGuard works is dynamic and is very specific to your application, we, on the backend side, we cannot foresee how you're going to use a particular library. So we have to tell you the worst case scenario, so the maximum number of methods that you are ending up with when you put this library inside your application. Of course, you're probably not going to use every method of a library, so the total count is going to be lower. But then again, this is an upper bound, so keep that in mind. So yeah, this is basically it. We learned that the limit is here to stay, at least at least until we're going to use MinSDK21, which is not going to happen at least for 1 year, probably 2. And we need to find the best way to deal with it. And the best way of dealing with it is not having to deal with it at all. So please try to be considerate and try to stay below the limit as much as you can. Again, Google's telling you that. If you do really need to go over the limit, know that there are 2 possible approaches, namely multi-dex by Google or using a secondary dex file. And yeah, this is basically it. I'm going to skip the routine because there is no time left. I don't know why. And yeah, this is it. So if you want to know more about the whole 65K methods limitation or multidex, please read these two very interesting articles, or follow me if you want to know more, or if you will have any questions, just you can take them offline because we don't have time left, or you can follow me on Twitter or Google Plus or whatever. Thank you.